We're going to talk about direct and inverse variation today. We'll just stick with direct variation. But it is true that this is the equation for direct variation y equal kx. Now, what is this called?
Slope.
Slope intercept. Now, this is your y-intercept. Okay, so if my graph goes through the what every time? A direct variation graph goes through the origin, then B is 0. Now what is this? What's the M stand for? Slope. Okay. That is the same thing as this K, which we're calling the constant of variation. So the constant of variation and the slope are the same. The proportion for direct variation looks like this. And today we're going to talk about using both of them. So we've got the equation y equal k times x and the proportion, which looks a lot like the slope formula, except there's equal signs instead of minus signs. But y1 over x1 equals y2 over x2. Just like the definition of slope. The change in y over the change in x. That's what this is saying. The y over the x. Here is an example that says if y varies directly as x. Now that tells you right there that two things should come in mind. If it varies directly, first of all, we have the equation. And then secondly, we have the proportion. Just the words varies directly. Hopefully those two things will pop up in your mind, okay? So if y varies directly as x, it says that the first y named here is 24, and the first x is 3. And we are to find the constant of variation, which means I've got to use this equation. And then I must find the second y when the second x is 2. All right, let me give you a chance to write all that down. Okay, so the A part says to find the constant of variation. So where is the constant of variation? It's right there in that equation. So we're going to take the y that was given to us and substitute in for y. And we're going to take the x that was given us here and substitute in for x. Solve for k. And k is 8. Now before Christmas, we were finding the constant variation. And then we were taking that constant and substituting it back in for the equation. Do you remember that? Alright, now that we know what k is, the b part says use that and find y when x is 2. So let's plug in what we know. We're looking for y. We just found out what k is and x is 2. Well, if k is 8 and x is 2, what's y? Alright, so if k is 8 and x is 2, what's y, guys? 8 times 2? 16. That is solving this problem using the equation for direct variation. Alright? Now I want to show you how to use the proportion show you how to use the proportion. Very simple. Well, how do you know which one's the first y, which one's the second y? The order it comes in the problem. So the first y is 24. So I'll put it right here. The first x is 3. So I'll put it in the place of the first x. One of these two is going to be missing. One of these two I'm going to be finding. And it is the second y. The second x is 2. How do you solve a proportion? cross multiplication. So let's cross multiply. 24 times 2 is 48. And 3 times y is 3y. To solve for y, we divide both sides by 3. What is 48 divided by 3? Yeah. Hey, it's the same problem. I should get the same answer, right? And I did. I get the same answer that I got right up there. So which method do you prefer? The direct variation equation or the direct variation proportion? I like the proportion. But I want to make sure you can do both, okay? Now, before Christmas in our textbook, we were running out of time in the semester, and all our book said was to find K and then plug it back in. Didn't direct us to go on and use that and find the missing information. But all you do past that is plug in the second part, find what you're needing, and that's it. But we did do this. We did do the proportion, so let's make sure we understand that. Let me scroll on through here and we'll find us another problem. There's my proportion. Okay, here we go. This says y varies directly. So again, we think about the equation and we think about the proportion. Now, in case you can't read this, this says that y is 6, x is 5. We're to find y when the second x is 15. That's what the problem says. Okay, and so what they've already done here for us is to substitute into the proportion. Okay, the first y is 6, so it goes here. The first x is 5, and so it goes here. The second y is what we're looking for, so we kept a variable. And then the second x is 15, and it goes here. Cross multiply, 6 times 15 is 90. 5 times y is 5y. Divide both sides by 5. And y is 18. That's using the proportion method. Pretty simple. What if we were going to use the equation method? Let's see if we can first of all find the constant of variation. Okay, constant variation. So the first y is 6 and the first x is 5. It's going to be a fraction, but we can do it. Divide both sides by 5. K is 6/5. Or if you prefer 1 1/5 or 1.2, that's a terminating decimal, so it would be okay to use that. That's not rounded off. And so we take K. It's better really to use an improper fraction there so that you can cross-reduce if it's possible. But we have substituted the K back into the equation. Now our second x over here is 15. Okay, so we can cross-reduce. 5 will go to itself 1 time, 5 will go into 15 3 times, and then 6 times 3 is 18. Same answer that we have down here, just a different method. Does this equation method make sense? We had been, finding K, plugging it in, but we didn't go further. All we had to do is one little more step there. And there's the proportion method. Okay, let you guys do this one. Y varies directly is x. X is 8. That's the first x. The first y is 9. We're looking for y when the second x is 12. All right, let's do it both methods. Let's do it with the equation and with the proportion. And we'll do it on the board for dollars.